For the Backup and Archiving in the AWS Cloud webinar. My name is Lowell Anderson, and I'm the Product Marketing Manager for Amazon S3 and Glacier, and I will be the moderator for today's event. Our speaker today is John Downey. John is the Senior Business Development Manager for the AWS Storage Services portfolio and is responsible for our enterprise storage strategy and the development of storage solutions for customers. John has been with AWS since 2011. Prior to joining Amazon, John worked for EMC for many years, mostly in the sales group with a specialty in network-attached storage and object technologies. Today, John will spend the first 40 to 45 minutes presenting reference architecture's best practices and use cases based on AWS services, including S3, Glacier, and the Storage Gateway. We'll try to leave some time at the end of the call for Q&A. During the call, please go ahead and submit your questions via the chat window, and we'll try to answer as many of them as we possibly can during the webinar today. If we run out of time, we'll collect the questions and we'll follow up with you via email. I'll go ahead and turn it over to John now, and thanks again for joining us. John?
Thanks, Lowell, and thanks everybody for joining. Good morning, good afternoon from where you're calling in today. Thanks for the introduction. So as Lowell mentioned, I'm on the business development team for our storage services. We have a group of 9 other business development managers that are aligned to our storage services portfolio. We are all over the world in different regions and geographies. Each one of us has a different responsibility as it relates to AWS's storage business. We are all uniquely positioned in the organization, working with product management, product engineering, field sales teams, field solution architects, as well as working closely with very many customers. So we have sort of a horizon / hub and spoke view of what's going on in the marketplace, and hopefully today you'll see value being brought across in this presentation as it relates to backup and archive. My individual assignment is our enterprise storage strategy. So what that means specifically is customers that own and operate data centers with an internal storage footprint. Many of them are looking to leverage cloud storage, and they don't know how to, and that's what this strategy addresses. So if you have internal storage operations and you're looking to federate with us, leveraging either block technologies, as in SAN, or file technologies as in NAS, or backup or archive or disaster recovery, we can help. And we have many ways to address each one of those different storage use cases. But today we're going to focus in on backup and archive. And one other thing I wanted to mention is that in late April, there was a significant cost reduction in our simple storage service, otherwise known as S3. There was a 51% pricing reduction. So the timing of this webinar is in time with that reduction as well. Okay, so moving on. So let's jump through the agenda. So we're going to talk first about why AWS for backup and archive. Then we're going to talk about the physical footprint of our data centers and where they're located in the world. We'll touch on backup and archive concepts. We're going to compare and contrast traditional backup and archive solutions and topologies versus a cloud approach for backup and archive. Then we're going to talk about, in the order of how backup or archive data would flow. We're going to talk first about the client. So that might be backup software that's integrated, or a backup gateway that the backup software is going to send data to within your data centers or in the cloud. Then we're going to touch on data ingestion options. So different connectivity options, different ways to get data in and out of AWS. And then finally, we'll talk about the bottom repository, which are different AWS storage options. Next, we'll run through some quick retrieval and restore concepts, and then finally we'll end on a note on TCO and then next steps. Okay, so traditional backup and archiving can be rather complex and expensive. For example, you'll have backup software. Many larger organizations will have multiple types of backup software. Sometimes you'll see one type of backup software at remote offices versus a completely different type of backup software at the core data centers. There's other scenarios where you'll see one single common global standard of backup software deployed across an organization or an enterprise. So backup software is a major component and oftentimes can be very costly depending upon how that is implemented. Then you have the target where you're actually going to be storing the data. These could be tape and tape-based systems. It could be disk-based systems. And then oftentimes you'll see customers that will send this data off-site, whether that means off-site vaulting, perhaps to Iron Mountain, which everybody probably knows of, or replicating to secondary data centers. So it can get very complex and it can get very expensive, especially over time. So in enters AWS, and the profile can change, right? First and foremost, there's no capital investment, right? Our services across the board are operational, metered utility style pricing with no commitment and no risky capacity planning. When it comes to AWS storage, Glacier and S3, as the bits and bytes come down the pipe, we're actually creating and managing the landing space on demand. So there is no essential capacity planning, and it is elastic. You pay for what you use. With these strategies, you're eliminating the need for legacy technologies in the context of legacy virtual tape libraries, disk, or tape platforms, which helps to eliminate the burden of tape and the potential of losing tape and handling physical media. And then finally, we have a variety of regions that I'm about to run through that you can choose to move your data to for a wide variety of use cases, but of course for backup and archiving in the context of this presentation. And you choose which region that data goes to, and that data stays in that region. We do not move that data. The only way that it will move anywhere else is if you have a utility to do that. So you can choose where you want your data to live for locality, performance, latency, compliance reasons, etc. We find that for customers that backing up and archiving is a great place to start with the cloud because first and foremost, it's a burden that can oftentimes be painful, especially with tape-based systems. Backup and archiving is not as latency sensitive versus production workloads. It's not production data, so therefore it's lower risk. And because of all these things, this is oftentimes an area where we'll see customers get started with AWS and the cloud. Okay, so let's take a look at our global footprint. So we have this concept of regions, and those are denoted by the stars on the map. Regions are made up of what we call availability zones that are all interconnected. I'm going to show that on the next slide. Availability zones are clusters of data centers. We are over 26 at this point. And not shown on this slide are what we call edge locations, which are our points of presence for or POPs for our CloudFront content delivery network. And also not showing on this slide are the physical locations where we have routers stood up where you can connect your private network to us. So you can get to us using internet, a direct connect, or even a physical disk shipment option, all of this which I'm going to go through in more detail. So this is where the physical operations reside. And if we flip to the next page and you take a look at each one of these locations, let's take US East, for example. And this is just conceptual, by the way. This is by no means the number of availability zones that we have. This is just a conceptual slide here. An availability zone is either a single very large industrial-sized data center or multiple of them near each other. You will have multiple availability zones, typically in a region. They will be anywhere from 5 to 25 miles apart from one another, interconnected on private Amazon fiber, high-speed fiber. And it's critical to understand this because certain systems, such as S3, Amazon S3 Simple Storage Service, and Glacier, which I will be talking about more as well, are distributed software frameworks that span all of these availability zones and all these data centers as one single service within that region. So in other words, if you have a backup technology in your data center and you're going to move your data sets to us, A best practice, for example, would be that that data is compressed, deduplicated, and encrypted, and then that data is going to move over to our systems over your choice of connectivity. And then once it reaches, let's say, S3, for example, S3 will then take each individual file, chunk it up into smaller bytes, and then spread all those bytes around all those availability zones and all those data centers within those availability zones, and then we do it again, right? So this is our own method of providing essentially parity overhead, if you will. Think of it as, you can think of it as RAID across data centers, but we do it redundantly. And this is what gives you a very high degree of data durability. We are designed for 11 nines of data durability, which means that statistically, for every 10,000 objects that you store, you can expect to lose one every 10 million years. And it also means that we can sustain 2 simultaneous events in a given region with no impact to system performance. So this is kind of the underbelly concept, right? These regions are designed with lots of thought in mind regarding redundancy, connectivity, floodplain levels, straddling fault lines if they're in existence. So lots of thought goes into each region, and then certain services, such as S3, such as Glacier, for example, span all of this geography within a region to provide one single storage resource. So I think that's very important to understand. So you got the regions where they are located. Beijing, by the way, the red star, is a current limited preview region that is about to go generally available. That's why I show that star as being red. And then we talked about the concept of availability zones and the distribution of the system by nature. Okay. So now let's move into backup and archive and kind of defining the difference between them, which most of you probably know, but let's just do a brief review. So backup is a copy of your more recent production data that is used for the purpose of restoration in the case of accidental data deletion, data corruption, data loss, or any other event that I may not have mentioned. Backup is going to have a certain performance profile specific to it, such that you have backup windows, which means you have a period of time with which you can complete your backups. So there must be a certain degree of performance in the backup system associated with that. And then upon the need to restore, you essentially need immediate, fast access to the data, and the system should also be architected to handle that type of recall and throughput. So that's kind of a high level on backup. Now, if we move into archive, it's much different. It's actually your production data that happens to be very old. So typically, it's a long-term retention play, usually very infrequently accessed. Latency is acceptable. And a customer would use this for, perhaps it's a creative customer that never gets rid of their content, and they hold on to and archive their content forever. Or perhaps it is an enterprise that has to deal with legal or internal compliance or regulatory compliance reasons, perhaps financial services or life sciences, for example. So all of these have different archive use cases potentially, but the profile is relatively similar for all of them. Sometimes you'll see customers that will combine archive and backup, so they'll use the same backup systems, backup software plus tape, for example, and then they'll send their tape offsite for long-term archiving. Sometimes that's very common. Other times you'll see customers separated into completely separate systems entirely. So just kind of a high level on the differences between backup and archive. So let's dig into more of a traditional backup and archive deployment that you commonly see today. Sometimes it can be painful from a recovery perspective, especially if you're restoring from off-site tapes that were in a vault. It can be capitally intensive, the software and the hardware, including any sort of ongoing upgrades and maintenance. It can be complex, especially when you consider tape management. I have yet to hear a customer say they enjoy managing tapes. And the quality can be low sometimes in the context of tapes getting lost, tapes breaking, or just a general error-prone process. So if we look at some of the technologies that make up a traditional backup and archive implementation. You've got backup software, many different types of backup software. For example, here's a smattering of some of them in the white box to the right. Each one of them works in very unique ways. They have their own formatting, their own index, a wide variety of different feature sets, and that in itself is a major investment of time and understanding as well as money. There's different topologies where you're going to deploy backup software. It may be core data center backup to cloud. You may be backing up remote sites. You may be doing all of them together under one single system. If you have decentralized backup and different backup software distributed around remote sites, that sometimes calls for dedicated people to be in that location, right? So there's lots of considerations here. There's tape silos and tape library options. There's different drive type options, which will dictate the type of media or tape you're going to back up to. Then there's the concept of virtual tape libraries, which became very popular about 6 years ago or so, which are controller-based disk arrays that emulate tape and tape drives. And then there is the concept, of course, of offsite vaulting. There are unified backup solutions, which are technologies on the market that are combinations of backup software and the backup hardware. And then commonly you'll see deduplication, compression, and encryption being core components of a backup solution. So let's look at a common topology for a traditional backup or archive implementation. So the right-hand side, for example, being application servers. Then you have your ISV media server, which is going to run the backup and move the data with agents on these servers over the network, perhaps to a disk target first, and then D-stage to tape. And then oftentimes that media server will replicate their Tier 1 data sets to a remote location as well for geographic diversity for their most important data sets. So that's one example. Another example is virtual tape libraries, right? And what's happened over the past 5 or 6 years with these technologies, very effective at doing data deduplication, data reduction, and giving a tape a run for its money from a longer-term TCO perspective. So this particular example shows multiple remote sites, so 3 sites on the left, 1 appliance per site, perhaps a localized implementation of backup software per location. Let's say backup exec, for example, which is a common find in remote sites. And it hits this local device, and that does dedupe compression and moves the data to a common hub, which would be a larger centralized customer data center. So there's a landing pad for all that remote site data. And then oftentimes, and you can see that that much larger system is going to drive much more capital investment. And then oftentimes you'll see a customer take this landing pad and replicate it yet to another location for even more geographic diversity. Extremely common to see 6-figure deals go out the door. Very common to see million-dollar deals go out the door for these types of solutions. So not cheap. Okay. So now let's move into what we're all here to talk about and learn about, which is cloud backup and archive and some of the options around this space. So you'll see the same slide I showed earlier, all the components. But when you consider cloud backup and archive, a lot of different systems just get cut out of the overall system topology. It becomes much more streamlined and therefore becomes much more operationally streamlined and easier to manage, as well as dramatically less investment upfront and over time. So let's go ahead and define those topologies first. So different ways customers need to back up, different scenarios, and then I'm going to back into the actual technologies that can make it come to fruition. So let's start first with a couple options. There's, of course, branch office backup to cloud. Very common to see customers start there. Typically, it's a lower risk area to get started. Customers will oftentimes then move into doing core data center backup to cloud, so a larger data center footprint that you're going to back up to either S3 or Glacier to AWS. And then oftentimes you'll see customers stop building new data centers and launching VPCs. A VPC stands for a virtual private cloud. That is a way to construct a private data center within AWS behind your firewall and on your private network. So you can build on-demand, unlimited number of resources from compute, storage, network, database, and many other things within AWS. And ideally, you want one tool to be able to back up all of this. And we can deliver this today, which we call hybrid cloud backup. So in all scenarios, whether you're on the cloud or in one of your data centers, the idea is that you're moving the data to the cloud, and you're going to be storing the data in the cloud. And there's a variety of recovery techniques we're going to talk about that mitigate latency. But the idea is, ideally, the Nirvana scenario, that you have one single management domain to manage all of this. Okay, so let's dig into branch office quickly. So common considerations. Either there's going to be localized backup software and somebody managing that, or it's going to be part of an enterprise global standard. There'll be some sort of backup target there. The target could be a client sometimes. Sometimes it's a virtual appliance, and you put some direct attached storage behind it. Other times it's a fully bundled appliance with internal disk. There's going to be, of course, WAN and or internet options to move the data from the branch office into the cloud. Dedupe compression and encryption and WAN acceleration are typically native components of these appliances that would be the backup target. So you don't necessarily need to invest in separate encryption or key managers. You don't necessarily need to invest in separate WAN acceleration to get good utilization of your WAN. So here's a common set of considerations. Now, if I move from branch office to core data center, what's the major difference here? Well, you'll see the list of considerations is basically the same. But the big difference is that in core data centers, you have a much larger data footprint. Some systems are designed more for remote office backup. Other systems are designed for larger single data center, large data footprints, right? So there will be some considerations from a backup software perspective there. But I think the biggest difference to consider with core data center backup to cloud is your connection, right? Because you have much more data. So bandwidth is obviously always a consideration, especially when there's massive data footprints, and also especially in the context of that first synchronization. So what you're seeing is some telco providers put together really unique, cool stuff with us. One of our private connectivity options, or our private connectivity option, I should say, is called Direct Connect. I'm going to talk more about that. And Time Warner Telecom has done a really nice job of folding our Direct Connect logic into one single common GUI where you can not only select the port speed on our routers, but also on demand burst up and down with your Time Warner Telecom telco model, right? So think of using this as bursting for a couple weeks to get that first ingest in, and then reducing the size of that bandwidth once it's in, just for your daily deltas and incrementals, for example. And if you have the proper type of deduplication technologies at these locations, full backups will typically be reduced down into really what becomes another differential. Okay, so we talked about edge. Now we talked about core to cloud. Now let's say you're starting to launch applications in the cloud, right? Maybe you just have other apps or newer applications that you're now running on EC2 within AWS within your VPC or virtual private cloud. Again, a very similar set of considerations to back those applications up. Most traditional backup software applications can run just fine on AWS, but they need to be able to get the data into S3 or Glacier. So some backup software options have their own native integration with S3 and Glacier. Those backup software vendors that do not, we can launch what we call AMIs, Amazon Machine Images of backup appliances, right? That looks like a VTL or it looks like a NAS. It runs on EC2, and then what it'll do is become the entry and exit point between the backup software and S3 and Glacier. So an AMI, for those of you that are familiar with VMware terminology, is equivalent to a golden master, but we call it an Amazon Machine Image. It's essentially a pre-bundled image from OS and App Stack, ready to light up at any time. For customers that are leveraging EBS, which is our in-cloud SAN storage, it has its own native snapshotting technology to S3, and that snapshotting software is free. The landing space is not. And then there's the concept of hybrid cloud, where you may be backing up everything to the cloud in concert. So You may have your corp, your branch offices. You may have new data centers that you've now launched in a VPC on demand. And ideally, the Nirvana scenario is you have one single common management domain, one GUI to manage all of this up, And once again, we can deliver this today through different technologies. Okay, so now now we talked about topologies. Let's move into the actual parts and pieces that can make this come alive. And let's start with what would go in your data center first. So I'm going to go through some options there. So different gateways, different backup software. After that, I'm going to move into connectivity options, so how you connect to the cloud. And then finally, different storage options in the cloud. So just kind of going in order of the data direction. Okay, so first and foremost, we have our AWS Storage Gateway. This is an iSCSI SAN appliance that you would download from the AWS site console. You can install it into VMware and Hyper-V on-premise, put your own disk behind it, and we can turn that server that's running that virtual machine into essentially an iSCSI SAN, and emulates an iSCSI SAN controller. Very low cost, $125 a month for the virtual appliance. There's a tremendous number of customers that have adopted this. Primary use cases for this iStorage gateway, iSCSI storage gateway, are I'll label it two ways. One we call backup with backup, and backup without backup. So what does backup with backup mean? So lots of customers will use their existing backup software. So let's say you have a master server for your backup software. You could take our iSCSI device, right, on premise, and mount an iSCSI volume to your backup master server, and then have all that data get redirected to that volume. And of course, the backup software is going to be doing the compression and hopefully the encryption and maybe the deduplication, depending upon the backup software vendor. It lands in our volume, and you'll have disk locally, so you'll get LAN and disk speed, and then we'll snapshot that data into S3, right? So that's using backup software with our device. We're calling that backup with backup, right? Backup without backup would mean putting, for example, a file server over our gateway. So perhaps you mount, you take our device and you present an iSCSI LUN to a Windows or Linux file server, which is also very common, and then our gateway will snapshot all of that data and that volume into S3. So we'll handle the backup of that server without the need for backup software. So that's our story with backup without backup. We do not have consistency hooks or VSS integration yet, by the way. But very, very cost effective and very compelling. We have different caching modes. One's a full mirror, so whatever's in the cache is also in S3. We have a different mode that we call cache volumes mode, which enables a much smaller disk footprint on-prem, but much larger storage capacity in the cloud. And you see all of that capacity as if it's on-premise, right? You'll deal with the physics and latency between the cloud and that device in that mode. There is full support for encryption. We offer a free encryption service called server-side encryption on S3 that is supported as well by the gateway. We've been able to push about 5 terabytes of throughput a day. You can expect to see improvements there. And there are different ways to recover. You can recover snapshots and data back to your on-premise location using our system, or our own snapshots from our gateway to S3 are recoverable in EBS, once again, which is our in-cloud SAN technology. So there's you can recover in the cloud, or you can recover back on-prem. Some interesting options there. In addition to our gateway, we recently came out with a new version of it. I believe it was around fall of 2013, if I'm remembering correctly. And this is our virtual tape library option. So we call this AWS Storage Gateway VTL. So we're using the same underpinnings of our iSCSI gateway, but we are now emulating 10 LTO4 drives, as well as emulating 1,500 virtual tape slots. Also $125 a month. You can build, as in the iSCSI gateway with this one, they can both be scaled up to 150 terabyte local cache, so you can build 150 terabytes of disk on-premise behind these devices. And in the context of this VTL system, you have two concepts. You've got a VTL, which is your virtual tape library. That means that your backup software would see an LTO target, and it's going to back it up to local disk. It's going to stay on that local disk and get replicated into S3. That's the VTL mode. There's another mode called or component called VTS, or the virtual tape shelf, which emulates taking a cartridge out of the slot and putting it on a shelf, and then typically that cartridge will go off site. What happens on our device is that the local copy on your disk will get deleted and replaced with a pointer, and then the object that's stored on S3 will get tiered down into Glacier, which is now the analogous of being off-site in a vault. So both devices, $125 a month. There was a 65% reduction price-wise on the volume storage for the gateway, as well as VTL storage for the VTL gateway, and that happened at the end of April. One other key thing to consider here, in the spirit of the kind of nirvana topology I showed earlier with backup, these devices can run on-premise, and they can also run on EC2. So they can run in your data center, and they can run on AWS servers as well, on EC2. So that means you could have one deployment of backup software, and you could have your master server on-prem and the agents backing up those application servers, pointing the data to a gateway, one of our gateways, which then moves the data into S3 or Glacier. And you may have media server components of that same backup software implementation also running on EC2, with that same backup software's agents deployed on other EC2 application servers, backing up to a virtual image of our gateway, and essentially you have a same mirrored topology on-prem and in cloud, all backing up to a common S3 and Glacier account. So you can extend your global common enterprise backup standard, if you have one, into the cloud, and we would essentially mirror the same network and backup topology. There's also a very robust collection of backup and archive partner solutions. I don't want to run through all of these, but some of these are backup software that are natively integrated with AWS. Others are appliances that you would use in conjunction with your existing backup software. Some are virtual, some are physical. Some are combinations of the backup software and the appliances. And others are applications that are integrated natively to our systems that can snapshot themselves, like Oracle, for example, using the Oracle Secure Backup Module in conjunction with RMAN. So let's talk first about one of our partners that's done a really great job integrating. This is Avere Systems. Now, Avere is actually a very high-performance, scale-out NAS system, but I'm using it in the context here as a NAS archival option and solution because they've done a really nice integration with Glacier. So the unique thing about Avere is that they can span archive to home directories to your most demanding NAS workload use cases, whether it's transcoding, rendering, seismic analysis, genomic sequencing, high-performance computing, to very simple stuff. So they originally started out as a NAS accelerator to accelerate reads and writes of legacy NAS between clients and a older NAS incumbent player that you may have on your floor. But what they've done over the past year is integrated both S3 and Glacier, which can become part of that same NAS namespace that you either had or reconstructed when you entered the device into your network. And then you can have scripts written or manually drag and drop content and files into a Glacier directory. And then what Avere will do is what they call freezing and thawing directories, folders, and files to and from Glacier. So they've done a pretty creative job here integrating their platform. So you could have something like this. They started small as a 3-node. They go up to a 50-node. It's also the fastest scale-out file system in the world, which you can see on spec.org. And you can use this system to not only handle all those use cases I mentioned earlier, but to also leverage your existing NAS plus S3 and Glacier all under a single common front end, which is pretty cool. So that's Avere's play. And again, not a backup solution today. This is meant to be for archiving in the context of NAS. Another technology that we see our customers leveraging often is Riverbed Whitewater, recently renamed Steel Store, but I wanted to keep Whitewater on here because it had brand equity. So Steel Store is Riverbed's first purpose-built storage device. This is not Steelhead. Of course, Riverbed's commonly known for their WAN acceleration. This is a purpose-built storage device. It's actually a NAS device that presents CIFS and NFS, but it is built specifically to handle backup software workloads. So that's streaming type of different workloads that come at it. So you can see a collection of different backup software that they support. They do all the testing themselves, so they know which backup software works very well and the nuances between all of them. And you can do direct database dumps to this device as well. So you're talking about an on-premise physical or virtual appliance, presents CIFS or NFS over your network to your clients, and then you would back up to this device, and it'll present or it'll produce roughly up to a 30x data reduction using their deduplication and compression. It also will do encryption, caching, key management, and WAN acceleration with S3 and Glacier support on the back end. So that means you can back your data up to this device, get LAN and disk speed, have it deduped and compressed and encrypted on your network locally. It'll hold it there for a period of time, but also replicate a secondary copy into the cloud. And the way that you construct these devices is you make the cache larger or smaller, depending upon whether you're using S3 or Glacier on the back end. And you want to construct this such that your restores and the concept of backup come from this box and not from the cloud. So you avoid and mitigate all the latency and all the bandwidth out charges, and you get LAN and disk speed restore. And if you're doing archive, they have a different type of data mover with no disk. It's just more of a data mover solution. So we see a lot of customers gravitating towards this, very impressive TCOs. I've seen TCOs versus traditional VTLs in the six-figure range with a customer that had 800 terabytes. I've seen a $1.4 million savings over 5-year TCO. So very, very financially significant. There's also an AMI available so that you can back up to Riverbed in the cloud as well. Cetera is another partner that's very strong technology, very creative. They're a combination of 3 technologies in one. They do enterprise file sync and share. So in other words, you could stand up your own private enterprise Dropbox or box, if you will. They also offer NAS appliances, so you can do NAS at medium-sized to remote-sized offices. And they also have their own embedded backup software, which of course includes their own catalog and their own agents. So this is software just like the other technologies I've shown you. These are technologies that you would own, and you would operate with your Amazon account. The portal, for example, is software that would run in your Amazon account. You would put agents on your servers, your laptops, your workstations. The agents do source-based deduplication, plus compression, plus encryption on the device before the data even trickles out the NIC. And then you can do different configuration options where that agent can move the data directly back to the portal running in AWS. And then that portal is an inline data mover that moves data down to S3. Or that agent can move data to a local NAS device to give you local LAN and disk speed. And then that device will snapshot the data back to the portal into S3. So there's different configuration options to help you mitigate latency here upon restores and backup as well. And then the final partner I'm going to talk about is Commvault. Commvault's done a very impressive job integrating with us as well. A single common code base, single index, where you have different solutions surrounding it in the context of archive, replication, backup. They've done a great integration with S3 and Glacier, dedupe, encryption, different topologies that are supported within their system as it's highly configurable, and a partner that we also see customers gravitating to pretty aggressively to move and back up and archive their data to AWS. Okay, so those are some of the devices that were on-premise, and I need to pick up the pace just a little bit here. There are a couple data ingestion options to consider as well. Obviously, there's Internet, which is very commonly used to back up and connect to AWS. There's Direct Connect, which is the private connectivity option, and then there's Import-Export, which is a physical device shipment option. So in the context of Internet, we have a bunch of tips and tricks that we work with our partners to make sure that they're optimizing that experience. There's a concept called multi-part upload, which enables client technology to take a large file, chunk it up into a bunch of smaller parts, and then upload them in parallel. There's another concept called request rate optimization that can increase throughput with S3 significantly. And there's also network recommendations. So we'll work with our customers and our partners to make sure that we're implementing these so that you get a good experience over the internet as well. And please understand that because the data is always encrypted at the source, that means that it's a very secure solution whether or not it's on a private network or not. On the construct of a private network, we call Direct Connect. This is a higher throughput, lower latency connectivity option. Okay, we have routers stood up in 11 different telco hotels around the world. We have physical 1 and 10 gig ports that customers can terminate their private network, MPLS or point-to-point, for example, onto us, and then have a higher throughput, lower latency, more consistent network experience versus the internet. But for backup and archive, you don't necessarily need this, but this is certainly an option, and we see customers utilizing this often. We have 5 locations in North America where we have routers stood up, 3 in Asia Pac, 1 in Ireland, 1 in London, and 1 in Sao Paulo as well. Okay, so those are the connectivity options. One more is import-export, and import-export is a physical disk shipment option so that you could back up data to a physical device, and then we have couriers take data to private locations where we can rapidly spin data into Glacier, S3, and EBS and rapidly get data off the platform as well. Okay, and then finally there are the actual storage platforms. So EBS is our high I/O in-cloud SAN system. You have S3, which is a high-performance synchronous in, synchronous out object store, and you've got Glacier, which is synchronous in, 3 to 5 hour wait on the way out, archive long-term retention / tape replacement system. So for EBS, the reason I mention a high I/O system is because many customers have their back-end storage volumes on EBS within AWS, and we have snapshotting software that will snapshot data into S3. The software is free, the landing space is not, and you get 11 nines of durability, of course, on those snapshots. We can also cross-replicate data across regions. That has to be customer-initiated. S3, as I mentioned earlier, a distributed high-performance object store, most commonly used for production, believe it or not, but also very popular for backup and archival use cases. We have multiple flavors of S3, reduced redundancy storage versus standard storage, so different parity options based on the customer use cases, which also affects cost. And, of course, I mentioned there was a 51% price reduction in general. It's a blended price reduction based on our tiers of capacities. We have recently released something new I want to mention, which is our server-side encryption service. We just released what we call customer-managed keys. So customers can now generate their own encryption keys and hand them to us with all of their gets or their writes to S3, and then we will use our service to encrypt, and then in order to unencrypt, the customer needs to resubmit that key to us. Right, so there's a new option we came up with there that is applicable for many customers as it relates to encryption, but in general, a platform that is growing very quickly. There's Glacier, which is a fixed cost, penny per gig per month. This, again, is more of a long-term archive tape replacement solution, also offering 11 nines of durability. And what we did, which is really cool, is we created a connector between the two. So you can actually tier data from S3 to Glacier, and you can do this to either clean up your existing S3 footprint, or a lot of the vendors have used the connector between S3 and Glacier as the way to get to Glacier, which is transparent to you as an end user. And again, this is fixed at 1 penny per gig per month, in contrast to S3, which is a tiered pricing model. Okay, really briefly, a couple of retrieve and restore examples. Customers oftentimes think that restoring data from the cloud will never work because it's going to take too long and their data set's too big. The idea is that this device in your data center is going to cache data that you've written to it for a period of time, and there will be a copy in the cloud. And the idea is that your retention schedules hang on to that data long enough in that local device such that the restores come from that local device and not the cloud, therefore mitigating WAN bandwidth and bandwidth out charges. So if there's Glacier, there'll be a 3 to 5 hour retrieval. We have a staging time. Or if it's coming from S3, it'll be immediate. But hopefully the data is in the cache and you get immediate LAN and disk speed restores. And then there's also the concept of restoring in the cloud as well, where you may have content that are archived in Glacier or data sets that are backed up to S3, and you want to do operational restores or retrievals from the archive. You can do that in the cloud and actually do disaster recovery in the cloud, different types of recoveries, or just monetizing new assets, for example, leveraging our systems. So if you're backing up, you can not only pump the data sets in, but you can create images of your application stacks. You can have scripts and third-party tools, then call upon those images to light up those servers on demand if something happens in your data center, and you can restore the data that you backed up in the cloud, redirect DNS, and have incredibly cheap recovery in the cloud, which could be viewed as a sort of poor man's disaster recovery as well, leveraging backup software. Easily a 75 to 80% TCO reduction versus traditional disaster recovery solutions. I'm not going to talk about all these items here. My point in showing this slide is that we have experts at Amazon that are focused specifically on TCO, and that we can help you put a TCO together. We also have our partners that will most oftentimes do the TCO for you as well, including the cost of the Amazon services. A variety of different customer wins. Again, we're short on time, but the point is here is these are all for the AWS storage gateway, where these customers either did file servers over our gateway or leveraged backup software to move data to us. So there's some happy customers here, and another use case as well, where this one customer, What's Up Interactive, saved over $1 million backing up and doing disaster recovery with AWS. So briefly, how do we get started? There is going to be an email sent out to everybody after this event. It's going to have a link where you can go to a website, fill out your information, and we will contact you and have a discussion regarding running a TCO for you and understanding more about your backup requirements. And just a real quick summary, at the end of the day, we have a very flexible platform here for archival and backup. We have different regions that are going to fit your compliance and business needs, a broad range of tools that are integrated with us that makes this a very powerful platform, very low cost, very relevant TCOs that you'll see, including an enhanced security posture, increased scalability, and significantly higher data durability in comparison to traditional systems, all at a lower TCO. So we think we've got a very relevant thing for you all to investigate here. So here's the link that will be emailed out to all of you for follow-up and how we do next steps. And with that, I'd like to thank you all for taking the time today, and I'll turn it back over to Lowell. Sorry, Lowell, I'm about 5 minutes over.
No problem. Thanks, John. I think you set a record for words per minute there at the end.
Sorry.
Good job. Thanks for all the questions, everyone. We are going to open up 3 poll questions over the next few minutes while we're answering some of the questions I'm going to give to John. So if you can go ahead and answer or respond to the poll questions, that would be great. John, we got quite a few questions during the call, and Xing and I have been trying to answer as many as we can, but we saved a few for you. Here's one about the Riverbed solution. With the Riverbed solution, does that present NFS and CIFS shares from S3 or Glacier storage, or is it local to the appliance?
It's local to the appliance. So you can implement, in your data center, you can implement their physical appliance, or they have a virtual appliance that will support multiple hypervisors. And it will locally present CIFS and NFS from the device over your network to your backup software. And then you'll cache the data in that device for a period of time, and then it'll do all the data reduction and replicate a copy into either S3 or Glacier, your choice.
Okay, great. One that we didn't have the answer for, John, maybe you do. Do you have to have virtual iSCSI storage appliances if you want to use Oracle Secure Backup to S3?
You do not. They have this what they call Oracle Secure Backup module that my understanding is works in conjunction with RMAN. And there's this construct of channels in Oracle that you can light up more or less channels to increase your throughput, and then RMAN will do RMAN consistent Oracle snapshots directly to S3 without the need for any third-party tool.
Okay. Another one we didn't quite know. is there a bare metal backup recovery solution for VM and non-VM Windows, Active Directory, file, and SQL servers?
So there is a bare metal and file level backup solution. Cetera offers that. I'm almost positive Cetera does. I might need to defer to them. I believe Commvault also offers that same type of functionality for bare metal and file level. Did I hear another level of backup as well that I missed?
No, I think that was it.
Okay.
John, we got a lot of questions, or several questions, I should say, about the internet bandwidth requirements and the time required to move data for initial backup and recovery. Maybe you could talk a little bit about the internet bandwidth requirements and different options for moving data into backup.
Yeah, that's a great question. So, you know, the biggest thing to think about, or probably the most challenging component of bandwidth as it relates to, you know, backing up or archiving to the cloud is obviously that first initial ingest. So it's not uncommon at all to see customers either A, up their bandwidth for a period of time, but I know that can be a pain, or B, it just takes a while to get that first initial synchronization. It can take months sometimes, depending upon the customer's connectivity. Now, remember that the gateways and the backup software and these data movers typically all do very aggressive deduplication and compression and data reduction, as well as chunking of files to maximize bandwidth any way they can. So there'll be data reduction plus any sort of WAN optimization. Then, of course, you're bound by physics, so it may take a period of time to complete that first initial synchronization. So while you're doing that first initial synchronization, if I can speak here, you also want to maintain your existing backup and archive solutions. So you'll essentially dual stream to your existing on-prem and to the new, and then once you get a full synchronization with the new, you just cut over to the new and you quit backing up or archiving to your old legacy on-premise systems. So it really is, it's really up to you how much bandwidth that you want to, you know, pay to your ISP, your internet service provider. That's why I mentioned those burst models in the construct of direct connect. But if you're okay with doing a synchronization over a period of weeks or months, which many customers are, as long as you're completing operational backups with your legacy systems during that first initial sync, it really shouldn't be a problem unless your back's against the wall for some particular time reason.
Okay, great. Another question about Windows. Are there recommended backup clients for S3 Glacier looking to back up a Windows file server with features like incrementals and point-in-time restores?
So, yeah, so some of the solutions are going to, there's a wide variety of options, right? There are technologies on the market that can offer, you know, CDP, so literally I/O by I/O synchronization, which is really more of a you know, continuous data protection, replication / you know, disaster recovery solution. There are other solutions that have snapshotting technologies built into them. If, let's say, you can buy a next generation file server that will present SIPs, and it will have its own VSS capabilities and right-click restore. There are other, if you're running a Windows file server, which I think the question mentioned, you can use backup software to back up a variety of Windows file servers with a variety of restore options. Some have VSS integration, some don't. So it's really, it's, you know, the way I like to describe AWS is we're a collection of services that are independent, that all have APIs attached to them, and somebody's either going to stitch together those services to create something, or you're going to plug something into it that's going to drive us. In the context of backup and archive, you're typically plugging in some other type of technology to drive our systems. So questions around VSS, consistency, application hooks, so on and so forth, is really dependent upon the vendor that you choose to use, and not so much on the actual AWS service as in S3 or Glacier. Hopefully that makes sense.
Yep. John, I think just one more question since we're getting near the top of the hour, and then we'll wrap it up. Here's one about RRS. Do you have a recommendation about using S3 RRS for backup, as we may not need the full durability of standard S3?
Yeah, absolutely. So if you have, RRS is a 4 nines of durability versus 11 nines for standard storage. So we recommend RRS to customers if they can easily reconstitute the data elsewhere, just in case something may have happened on AWS. So, for example, if you have an on-premise copy of your backup, maybe it's on tape, and you're backing up to S3, there's really no reason to use standard. RRS would be a great example there. That way you have a local copy, and you have a copy on us, and if you lose it on RRS, no problem, you can restore from tape locally. So the general message is if you can easily restore from yet another source or location, RRS is very acceptable.
Okay, great. Thanks, John. Terrific job. We are just a minute or two away from the top of the hour, so I'm going to go ahead and close. I appreciate all the questions that we did get. We've tried to answer as many as we can. We have a few left. We will follow up with you via email for answers for those. In addition, over the next day or so, you will get a follow-up email that will have links to both the presentation recording, as well as we'll share this deck out in SlideShare for you as well. And then there is also a link in that to, of course, to some applicable landing pages, as John covered at the end of his deck. So we're going to go ahead and close the webinar now. Thanks, everyone, for attending. Thanks, John, for doing a great job as a speaker. And have a great